And now, coming to you live from the restaurant at the end of the universe, Pre-Calculus Math 11. Dance. 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 Today, section 9.2, Quadratic Inequalities in one variable. Quadratic inequalities in one variable, just the x variable, not y. It's really just easiest to start in with an example, so here we go. Identify the x values for which x squared minus 3x minus 10 is greater than 0. There's two ways to do this. One is to consider the graph of the corresponding function f of x is equal to x squared minus 3x minus 10 and ask yourself, for which x values is f of x greater than 0? And it's fairly obvious here that it's going to be all the x values to the left of the first 0 and all the x values to the right of the second 0. And we can see those zeros very clearly as well over here on Desmos. Whether we solve algebraically or graphically, the zeros are the key points. They're the hinges. You can see on one side of the 0, the function is positive, and on the other side, it's negative. Unless, of course, the parabola only touches but doesn't cross the x-axis. Solving algebraically, I would find the zeros, like this. Once I get the zeros, I would put these points on the number line. And remember that right at -2 and 5, I either have to put a shaded circle or an open circle. Since the inequality is greater than, I'm going to put an open circle at both points. We don't want equal to 0, we want greater than but not equal to. So we know it's going to be one side or the other from here. If I look at this number line, I can see that it's separated into three distinct regions: x less than -2, x between -2 and 5, and x greater than 5. To determine which of these intervals is where the solution is, we can pick a test point in each interval. So let's go to the first interval here, and let's test -10. -10 squared minus 3 times -10 minus 10 greater than 0. This is 100 plus 30 minus 10 greater than 0. Yeah, I don't even have to finish calculating that. I know that's going to be true. Let's test the next interval here. Between -2 and 5. Hey, there's a nice number in there, 0. Let's test 0. 0 squared minus 3 times 0 minus 10 greater than 0. Is minus 10 greater than 0? No, minus 10 is not greater than 0. This interval is not the solution. And finally, let's test to the right. This last interval, greater than 5. Let's go with 10 again. 10 squared minus 3 times 10 minus 10 greater than 0. This is 100 minus 30 minus 10 greater than 0. Yeah, that's going to work. So, the intervals for the solution. If I graph it on the number line, less than but not equal to -2, or also x greater than 5. And I also want to just state what these intervals are. This interval is x greater than 5, and this interval is x less than -2. And there is the solution to this inequality. Simple. Alright, now let's try one more. Solve this inequality and state the solution or solutions and show the solutions on the number line. So we've got 5x minus 2x squared greater than or equal to 3. So again, what I would do is just concern myself with the zeros first of all. So I would look at -2x squared plus 5x minus 3, and I'm just going to look for where is this equal to 0. Now I don't like that this starts with a negative, so I'm going to multiply everything in this equation by -1, which gives me 2x squared minus 5x plus 3 equal to 0. Now, I have to solve this quadratic equation. I could do it by factoring, I could do it by graphing, I could do it by quadratic formula. I'm not sure if this one factors, so let's try quadratic formula. Quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. This gives me negative 5, so positive 5, plus or minus the root of negative 5 squared is 25, minus 4 times a times c. Well, a times c is 2 times 3, that's 6, and 4 times 6 is 24. So 25 minus 24 all over 2 times 2, which is 4. This gives me 5 plus or minus the square root of 1, which is just 1, all over 4. And this gives me either 6 over 4 when I do 5 plus 1, and when I do 5 minus 1, it gives me 4 over 4. And so I get two solutions out of here, those being 3 over 2 or 1. 3 over 2 also being 1.5. So we know on the number line, so I'm going to put circles here at 1 and at 3 over 2. Actually, I'm going to shade them in because the inequality is greater than or equal to. And now I'll pick some values in each of the three intervals here to test whether or not that interval is the solution for this quadratic inequality. So a good number over in this interval to test would be 0. So test the original inequality. 5 times 0 minus 2 times 0 squared greater than or equal to 3. 0 greater than or equal to 3. No, this is not part of the solution. I'm pretty sure now that this middle region will be the solution, but let's just test it out. Let's pick a number between 1 and 3 over 2, between 1 and 1.5. How about 1 and 1/4, or in other words, 5 quarters? So that will be 5 times 5 over 4 minus 2 times 5 over 4 squared. Is this greater than or equal to 3? That is 25 over 4 minus, now 5 over 4 squared is 25 over 16, and when I multiply that by 2, that's actually just going to be 25 over 8. Is this greater than or equal to 3? Well, 25 over 4 is also the same as 50 over 4, 50 over 8, I should say, and minus 25 over 8 just leaves us with 25 over 8. Is that greater than or equal to 3? Well, 24 over 8 is 3. This is 3 and 1/8. So yes, this is greater than or equal to 3. Everything in the interval between 1 and 3 over 2 will be part of the solution. And I'm pretty sure this final region is not going to work, but you know what? Pretty sure is not good enough. We just need to test it out as well. So I'm going to pick a number way out here like 10. 5 times 10 minus 2 times 10 squared greater than or equal to 3. So 50 minus 200 greater than or equal to 3. No way. So we've got our solution. It's the interval between 1 and 3 over 2. Writing that algebraically, I say 1 is less than or equal to x, which is less than or equal to 3 over 2. There is the solution right there, and you can see the 3 test points that we did down below. And now it's time once again for Two for You! Question 1. Is the value of x equals -3 a solution to this inequality? And question 2, solve the inequality below, give the solution algebraically, and show it on a number line. Sounds like fun. Sounds like a lot of fun to me. I'm going to save this one for Friday night. And while I'm doing it, I will dance, dance, dance.